This question is asking us to find the function, expression, and the point at which the derivative is being found. This is question 10 from quiz 2A. So in order to answer this question, I need to know what the definition of the derivative is. Okay, so I'm going to write those first. There's two different definitions of the derivative at a point C. One of those is the limit as h approaches 0 of f of c plus h minus f of c all over h, and the other one is the limit as x approaches c of f of x minus f of c all over x minus c. So this tells me that it is the derivative of a function at a point, and that's what I'm trying to find. So first of all, let's write what we're looking for. So we're looking for f of x equals what and at what point. Now, looking at this notation, I can tell because this does not say h equals 0 that I'm going to be looking at this second form. So since I'm looking at this second form for the definition of the derivative, or the alternate definition, the first thing I'm going to pull out is actually the c value, okay? Since I have x approaches c as my limit, that tells me right off the bat that my c value is going to be 9, because this is x approaches 9, and because I have an x minus 9 down there. So that means that this is in the same spot as f of x, and this right here should be f of c. Now, I am going to double check that. F of x, 6 over root x. If f of x is 6 over root x, we need to check what is f of our c value, which is 9. So we would get 6 over root 9, which is 6 over 3, which is 2. That does match what I have right here, so this works out, okay? So this is the easier of the two forms to identify your c value and your function, and I would, because it's the alternate definition, and I would start by finding c, and then f of x should be whatever is right here. This is the one you just need to verify, okay? I do have a couple more examples that I want to go through explaining this and showing you with the other form, okay? So let's say this one says the statement, this represents the derivative of a function at a point, and we're trying to find that. So this is using the first definition, which is this one over here, and I know this because I have the limit as h approaches 0, and I've got this h by itself in the denominator. So using that form, that tells me that this expression right here is f of c plus h, oops, and this right here is f of c, okay? So I know that f of something is equal to 1, and that f of c plus h is tangent of pi over 4 plus h. So first thing I want to do is figure out what c is. I look for where the something plus h is, the constant plus h, and I see that the constant in that spot is pi over 4. So that tells me that c is equal to pi over 4, okay? And then if f of c plus h is tangent of pi over 4 plus h, or f of pi over 4 plus h is tangent of pi over 4 plus h, then that means f of x is equal to tangent x. Okay, because f of pi over 4 plus h is equal to this. Okay, does that make sense? So what is the question I'm asking myself is, what is happening to the pi over 4 plus h? And it is inside a tangent function, so that means f of x is tangent x. I do want to verify what f of c is, that f of c is equal to 1. Okay, so I'm going to plug pi over 4 into this function. Is tangent of pi over 4 equal to 1? Yes, it is. These next two examples are similar to the ones that we just did, but they're asking something a little bit differently. And it's more likely that you will see a question like this on a test, or like an AP test or AP practice or something like that. The reason is because it's not really just about identifying what your function is and at what point, but it's about being able to answer a question by recognizing the derivative and a point. So looking at, oops, looking at these two examples, here it doesn't say, hey, this is the derivative of some function at some point. It just says to evaluate the limit. But here's the thing. I don't want to go through the process of evaluating this limit using all of the algebra stuff that we did in Unit 1. Is it possible here? Yes, it is. Sometimes it would not be, but here it is. I just don't want to do all of that. So instead, a better way to solve this question is to recognize, because of the h equals 0 here and the h here, and because there's an expression with h minus a constant, there's a really good chance that this is of the definition of the derivative form, so that this probably is the limit as h approaches 0 of f of c plus h minus f of c all over h. I'm just rewriting it down here, okay? So this is how I need to check this. The first thing I need to do is identify what my c value is. So again, I'm looking to see what is happening to the h. So if this is f of c plus h, then c plus h must be negative 1 plus h, or in other words, c is equal to negative 1. Okay, so the point at which the derivative is being taken is at negative 1. And then to identify what f of x is, I need to look at this expression and ask myself, what is happening to the c plus h, or what is happening to the negative 1 plus h? In this case, we have 1 over 2 times that quantity squared. So if I want to write this as f of x, I need to write 1 over 2 times the new input x squared, so 1 over 2x squared. Okay, now I can check this by asking if f of negative 1 is equal to negative 1/2, so we can check that. 1 over 2 times negative 1 squared, which is 1/2. So yes, that works, meaning that this is f of c. Okay, so the point is that this is the definition of the derivative of the function 1 over 2x squared at the point c equals negative 1. So to evaluate this, I can use my rules for derivatives, my shortcut rules for derivatives, take that derivative and then plug in negative 1. So f of x, I'm going to rewrite this as 1/2 x to the negative second, just so I can use an exponent instead of a quotient rule. Okay, so f prime of x, we're looking for f prime of negative 1, would be equal to, so moving that down and multiplying with the power rule here, I'm going to have negative 1/4 x to the negative third when x is equal to negative 1. So that's negative 1/4 times negative 1 to the negative third, which is just negative 1. Negative 1/4 times negative 1 is positive 1/4. Then for this last one, again, we have an expression and we are asked to evaluate this. I don't want to do this algebraically, but I want to recognize that this is the definition of the derivative, the alternate definition of the derivative, which is limit as x approaches c of f of x minus f of c over x minus c. Again, same thing I had up at the top, I just wanted to rewrite it down here. Okay, so this one is easier to identify what my function is and what my c value is, because I can see what's written right here. Get it, c? Sorry. All right, so I can see that my c value is 1 over e, and then also since f of x is right here, that means that my function is the natural log of x. Natural log of x. Okay, so now, just because I've identified that doesn't mean I'm done. I still need to take the derivative. So if f of x is natural log of x, then f prime of our point, 1 over e, is equal to f prime of x, which is 1 over x at the point when x is equal to 1 over e. So we get 1 over e, which is equal to e.